morning, ladies and gents. Okay, we are still in trig graphs, and what we're going to look today is amplitude shift. Not a big deal. Okay, the tough lessons were before when we build the graphs. Now we're just adapting them a little bit. Not too difficult. So I start by drawing a graph of y equals sine theta. This is this blue graph. Okay, I'm hoping you're starting to get used to this wave. It starts at 0, swing to 1 at 90, goes back to 0, 180, at 270 it goes down to minus 1, not at 2, and goes up to 360. I'm going to give up after 360, we don't need it for now. What I'm asking us is, what I'm trying to find out, if this is the graph for y equals sine theta, what will be the graph for y equal 2 sine theta? Okay, I just put a 2 in front of the sine. Okay? Now, all I've got to do really is each one of these points, simply double it. Okay? Now, there are some points, and I already mentioned to you these really important points. It's that 0, it's that 90, it's that 180, 270, 360. Some special values that the sine takes. Right? So all I'm going to do is just double everything. So when y equals sine theta was 0, then 2 times 0 will be 0. When sine 90 is 1, then 2 times sine 90, 2 times 1 will be correct. It will be 2. When sine 180 is 0, 2 times 0 is still going to be 0. And when sine 270 is minus 1, 2 times minus 1 will be minus 2. Lastly, sine 360 is 0, so 2 times sine 360 is also going to be 0. Okay? All I did really is multiply each one of the y value here by 2. So now if I'm looking, maybe I should draw it with purple. Okay, so I'll draw these purpley dots. Okay? Purpley dots. When I would really recommend you to look first of all at 0, 90, 180, 270. Just draw these points and draw the curve between them. Okay? So the 2 times sine theta would look like that. It's still a wave. Okay? It still have a maximum and minimum. Different one. The maximum is 2, minimum is minus 2. The amplitude now is half the difference between 2 and minus 2, so the amplitude is 2. The range is between 2 and minus 2, and the period is still 360. But that's how I recommend you. I mean, you don't need to look at each one of the value of sine theta and double it. Just look at the basic ones, 0, 90, 180, 270, 360. Okay? So is that 2 sine theta? Easy, isn't it? Okay? I'm going to pause that, and we're going to do the same thing for cosine. Okay, silly me, sorry, before we move to sine, I wanted to give you, before we move to cosine, I want to give one more example. So on top of these two graphs, sine theta and 2 sine theta, I want to plot minus half sine theta. So how do I do that? Again, I go with these little important points, and I ask myself, what will be the y value for minus half sine theta? And all I've got to do is find sine theta and time it by, correct, minus half. So sine theta is equal to 0 here. What is minus half times 0? No problem. It's still 0. 0 times anything will be 0. Sine 90 is 1. 1 times minus half is minus half. So I'm going to put minus half here. Sine 180 is 0. So minus half times 0 is still 0. Sine 270 is minus 1. So minus 1 times minus half is actually plus half. So I'm going to have a half here. Sine 360 is 0, so minus half times 0 is still there. Now I can see this graph. Okay? The top, the maximum and the minimum points and the 0 point. And I'm just going to draw a nice curvy graph. Please guys, a curvy. Don't draw these little sharp ones. Make them nice and curvy. And that is minus y equal minus half sine theta. My dogs are growling. Okay? It's on my stomach. Okay? Now let's have a look at one of these things. The values, the maximum, the minimums are now not 1 or 2, they're half and minus half. That means the amplitude decreased. The amplitude is now as half, the distance between half and minus half, which is half. So check out something here, okay? The number that I've got here in front of the sine theta, not including the minus, is your amplitude. The number here is also the amplitude. So the number that is in front of the sine is actually your amplitude. Okay? Here, what number I have before sine theta? I don't have a number, so it's like I multiplied by 1. So 1 is your amplitude. Okay? But the other thing that happens here, and you can see the amplitude is smaller than the amplitude here. It's just half, the distance between half and the 0. But the other thing that happened to the graph here, it's flipped. Look, what did the sine do here? It started going up, and both the blue and the purple went up, and then it went down, and then it went back. The green, the minus half, it actually started going down first, and then it went up. Why did it flip? Aha, because I've got a minus here. So that minus flipped it. A normal sign, a positive sign, will go up first, then go down, then up. If I've got a negative sign, it will go down first, and then up. Okay? I'm going to pause here, and now we will do one example of a cosine.